Hi everyone, welcome back and thanks for coming. In this sequence of lectures, I'd like to talk about the various measures of association we epidemiologists use to link risk factors with outcomes. And let me give you a roadmap of what I'd like to do in terms of these series of sequences for this week. First thing I want to do is I want to introduce the idea of causality, introduce the idea of causal effects. So that's what I'm going to do in this first lecture. And then I'm going to try to link that up to the measures of association that we're going to be talking about this week. And I'm going to be talking about various measures of association. I'm going to begin talking about risk ratios and rate ratios, and risk differences and rate differences, building what we did in the last sequence of lectures. And then I'm going to move on to talk about another measure of association, namely odds ratios and some of the nice properties of odds ratios. And then I'm going to talk about some other less often used measures of association. I'll talk about proportional measures of association. I'll talk about the concept of number needed to treat in clinical epidemiologic research. And then I'm going to end up talking about regression models, introduce the idea that a regression coefficient is a measure of association. Now, throughout this, I'll give you some examples, some problems to do using the Framingham data set. So that's the roadmap. That's what I want to do for this series of sequences. But to start out, I'm going to give you two examples to try to relay the notion of causal effects. And the first one has to do with politics, how epidemiology and politics might be running into each other, especially at this time of the year. There's an election going on in our country to elect a president, and one of the candidates is our current president, Barack Obama. And what everyone is thinking about these days is how effective has Barack Obama been as a president. If you like the job he's been doing, you might tend to re-elect him. If you think he's been doing a less than optimal job, you might prefer to elect the alternative candidate who's running. But what does this have to do with epidemiology? Well, if we're talking about the effectiveness of a politician, we're talking about what outcomes happen to us and to our country during his tenure as president of our country. What sort of outcomes could we link to having him as president? So first, let's talk about this notion of effect, because epidemiology is predominantly trying to identify causes of diseases, or clinical epidemiology is trying to identify outcomes of clinical decisions. In both cases, we're looking at effects. What influence does one factor have on the occurrence of another factor? So conceptually, effects deal with consequences of a risk factor or the result or the impact of a risk factor. We've been referring to those as the outcome of this particular risk factor. What does it cause? What does it bring about in a group of people? Well, if we're thinking about effects, we have to be thinking, and we're trying to measure these effects, we have to be thinking about what would have happened if this cause did not exist. So when we quantify the effect of an intervention, say, what we're trying to do is estimate in our minds what would have happened if this particular cause did not exist. So going back to President Obama, what we'd like to be thinking about is what would our state of our country be today if Barack Obama had not been our president for the last 3.5 years. And we can compare that to what we feel is the state of our country today, and any difference in that comparison would reflect the effect, the influence that President Obama's presidency has had on our country. So what are our options? How are we going to come up with an estimate of what our country would be like today if Barack Obama had not been our president, if he had not been elected 3.5 years ago? And I'm going to present two options for trying to come up with this estimate. The first one is the one I've been hearing all the time on the radio and on television during campaign seasons. People are asking us, are we better off today than we were 4 years ago, before President Obama took office? So this is the first point of reference I want you to think about. Compare a state that exists today to a state that exists sometime in the past. In terms of this election, we're asking about our lives today versus our lives 4 years ago. If things are better than 4 years ago, we might say Barack Obama's been doing a very good job. If things are not as good as they were 4 years ago, we might say we'd be better off without having Barack Obama as our president. So what this is using as a point of reference is a pre-Obama presidency point of reference. Essentially, what was the country like when he became president? And are we better off today than we were back then 4 years ago? Now, the problem with using that pre-Obama presidency point of reference is that it's assuming that if Obama had not become president, what existed 4 years ago would have stayed true for the next 4 years. That what we could do is when we compare life today to life 4 years ago, we are essentially comparing life today versus what life would have been today had Obama been not president. And lots of things change over time, and that's going to be one of the problems in using this pre-point in time, pre-presidency point in time in this example as a point of reference. So what alternative options do we have? Well, option number 2 comes closer to the idea of causal effects. What we'd like to consider, what we'd like to be thinking about is, what would our life be like today? Not 4 years ago, but what would it be like today if Obama had not been president? We epidemiologists refer to that as a counterfactual outcome, and I'll talk about counterfactual outcomes in a minute. But what it involves doing is imagining this country under a scenario where everything else was the same in terms of what's happening to the world, except 4 years ago, President Obama was not elected as President of the United States. Now, that's difficult to imagine. What do we mean by what would things be like today if if Barack Obama had not been elected as president? Well, who would have been president? Would it have been the person who ran against Obama 4 years ago? Would it be the person who's running against Obama today? Would it be a random person? Would it be Marcello Pagano, which is an interesting thought as a person running as our president in our country, and I think he would do an excellent job, by the way. But first of all, the question is hard to phrase, but essentially what we're asking ourselves is what sort of things would not have happened if Obama had not been president? That's what we're trying to ask ourselves. And the problem, when we think about counterfactual outcomes, we cannot measure them directly. We can only measure what happens after Obama became president. We cannot directly measure what happened had Obama never been president. Well, to try to tie this a little bit closer to epidemiology, now let's talk about the Framingham data set. Let's suppose I wanted to answer the question, what's the effect of smoking on the incidence of developing coronary heart disease? How would I go about trying to design a study? How would I go about trying to measure outcomes to answer this particular question? Well, what I'd love to do is the following. I'd like to measure the causal effect of smoking by doing this comparison. Let's suppose I could take a group of people, and for sake of an argument, let's suppose I take a group of people who are smokers. Say I take the smokers in the Framingham Heart Study. I follow them, as you have in your data set, for 24 years and see how many of them develop heart disease. We can measure that. That particular outcome is something I can measure. I can tell you exactly how many cases of coronary heart disease developed out of these smokers in my Framingham Heart Study. What I'd like to be able to do is somehow take those smokers, put them into a time machine somehow, bring them back in some point in time in their life where they started to smoke and somehow change their decision-making process at that time so that those same people never became smokers. And then what I'd like to do is follow those same people over time. The same people who were up before were called smokers. I'm going to follow them for the next 24 years and now see how many of them get coronary heart disease. That's what I mean by counterfactual outcomes. What I'm measuring are two outcomes on the same people. One under the stipulation that those people are smokers, one under the stipulation that those same people now are non-smokers. So I would observe two different outcomes, two different counterfactual outcomes for each individual. One under the scenario that they were a smoker, one under the scenario that they're a non-smoker. Now the problem in real life is I can only measure one of those outcomes. I can measure what happens to a person if they're a smoker. I can measure what happens to that person if they decided not to be a smoker. But I can't essentially put people back into time machines and change their decision process and change that same smoker to become a non-smoker. So only one of these outcomes can be measured directly. And so for a single person, there's no way I can measure these two counterfactual outcomes. But for groups of people, I might be able to estimate what would happen to that group of people if all of them had smoked and if all of them didn't smoke. And that's where epidemiology comes into play. We're going to use another set of people, non-smokers, to estimate what would have happened to the smokers had they never smoked. And that's where the measure of associations that we'll be talking about in this series of lectures come from. So how do we estimate these causal effects? What we're going to do is compare the incidence of coronary heart disease in two different groups of people. One group of people are going to be people who smoke. We're going to follow them forwards in time and see what happens to them, how many of them develop heart disease. And then we're going to take a different group of people, the non-smokers, those who didn't smoke. And we're going to follow them and see how much heart disease develops among those over 24 years of follow-up. And then we're going to build a measure of association, something like a risk ratio, a rate ratio, an odds ratio, things I'll define in the future lectures, that links, in a quantitative sense, presence or absence of smoking with the development or not development of coronary heart disease during the 24 years of follow-up. Now, the big million-dollar question is whether that measure of association that I can calculate in data like you have in your Framingham data set, whether that measure of association really reflects the true causal effect of smoking on incidence of developing heart disease. And to argue that the measure of association really reflects causality requires that we as epidemiologists convince ourselves and others that we don't have problems. We don't have the problem of confounding. It requires that our two groups, our smokers and non-smokers, be similar with respect to other risk factors for developing heart disease. For example, if our smokers were all old and our non-smokers were not all young, then the outcomes I see among my young non-smokers won't reflect what would have happened to my old smokers had they not smoked, because there's two differences in the groups I'm comparing, the young non-smokers to the old smokers. I'll define confounding more carefully, more specifically in a current lecture, but essentially to argue that your measure of association reflects the true causal effect of a risk factor, it means that the two groups I'm comparing that are different with respect to that risk factor, smoking, non-smoking, are not different with respect to other risk factors that cause the disease. They are essentially comparable. The other problem I have to convince myself doesn't exist, or I have to avoid somehow in my study design, is that my study be free of bias. That my measure of association in terms of my selecting people for the study and my measurement of outcomes on those people are done correctly, so that the answer I see from my measure of association truly reflects the true causal effect that would have existed if I didn't have those biases. So bias and confounding are problems the epidemiologist has to either identify and avoid in the design of a study, or at least for confounding, you have to adjust for it in the analysis of the study. So let me leave you with this in this first lecture by giving you a picture of what I've been trying to describe. Let's suppose I want to know the effect of smoking, the causal effect of smoking on the incidence of coronary heart disease. Let's suppose I have your Framingham data set, all 4,434 people. Some of them are smokers and some of them are non-smokers. So this first box here describes all 4,434 people. The red shaded region represents the smokers in that group. The blue represents the non-smokers in the group. To measure a causal effect, the true causal effect of exposure, what I'd love to do is imagine what would happen to all 4,434 people had everyone smoked. So this first arrow says, let's suppose there's some way I could change history. So all my non-smokers actually became smokers. So what I'd have is a study of 4,434 people, all of which are smokers. And I could see how many outcomes occurred among those 4,434 people. Then I'd like to conceptualize at least what would happen if I went back to my original study, somehow took my smokers and somehow changed their histories so that they became non-smokers and now follow all 4,434 people under a different scenario. None of them are smoking. all of them are non-smokers. It'd be the same 4,434 people. And what I'm observing is how much heart disease occurs among those people if none of them smoked. Any difference between the number of events, the number of outcomes, under the situation where everyone smoked versus the situation everyone didn't smoke would reflect the true causal effect of smoking. That's what I'd love to do. Now the problem is I can't do that. What I can do is estimate that causal effect. Because what I can measure is the following. I can go back to my Framingham Heart Study and I know who is a smoker and who is a non-smoker. I can measure how much disease, coronary heart disease, occurs just among the subset of smokers. I can measure how much heart disease, coronary heart disease, develops just among the subset of non-smokers, and I can compare those two measures, those two incidence rates, those two cumulative incidence or those two incidence rates, to come up with a measure of association. Now, when will this measure of association estimate the true causal effect? Well, it's when the non-smokers, the blue box, estimates what would happen to the smokers had they never smoked, which is the same thing as saying the red box, the smokers, estimate what would happen to the non-smokers had they never smoked. And that requires that we be free of confounding in our study and free of bias. And those are two topics we're going to be talking about a lot in the coming weeks and the coming sequences that I'll be talking about. But for today, the argument I wanted to make is that we can measure associations between risk factors and outcomes, but whether those measures of association really reflect the true causal effect of that risk factor and the outcome depends on whether our data is free of confounding and free of bias. And more to be said about that in the future. See you next time.